Hello and welcome to Billy Bluebird. That's correct. Hey, this is an on your own problem, so you should have solved the entire problem on your own, and now you have your paper in front of you and you are ready to check your work and make sure you did everything correctly. So let's get on with the scenario. Meet Billy Bluebird. He is a proud bird and says that from his talons down here, right? Way down here to the tip of his tail feathers, that he stands over 4 inches tall. When he was measured, he stood 8.89 centimeters tall. Now, there are 2.54 centimeters in an inch. Does Billy Bluebird stand taller than 4 inches high? Exactly how tall is Billy Bluebird when measured in inches? Inches? How about just inches? Okay, let's go ahead and solve this problem. Now, the first thing you got to realize is that in actuality, Billy Bluebird is 8.89 centimeters tall, right? Now, there are 2.54 centimeters in an inch, right? So this is really a division problem where we're taking 8.89 and we're dividing it by 2.54. Now, as I have said many a time, your divisor really needs to be a whole number. So what I want to do here is I want to take this and I want to multiply it by the giant 1, right? Oh, what a beautiful one that is. And since this is in the tenths and hundredths column, I need to multiply this by 100 for my denominator, right? And whatever I do to my denominator, I got to have the same exact number for my numerator, right? Because I'm multiplying by 100 here and 100 here, that makes this fraction a 1, right? And then if I multiply any number by 1, I get that same number. It just looks a little different, right? So I'm going to now multiply 8.89 by 100, and I will get 889, right? Draw my equal sign in. Then down here, 2.54 times 100 will give me 254. And right now, as you see, I have a whole number for my denominator, or my divisor in this case. Fractions can be thought of as a fraction, right? 889 over 254, or 889 254ths. Or you can say 889 divided by 254, right? So how does this relate to our division? Well, let's go ahead and create an area box. And if we put our original number in here, we've got 8.89, right? And then over here, if we put the 2.54 out here, a lot of times in school we're taught, hey, move this 2 places. And I always use the word loop-a-doop, right? 1 loop-a-doop, 2 loop-a-doop. Or I'll go like this. I'll go 1 loop-a-doop, 2 loop-a-doop. And I use the word loop-a-doop just because it's goofy enough that kids will remember it. And then if you do 2 loop-a-doops here, you got to do 1 loop-a-doop, 2 loop-a-doops, and your decimal will go right there, right? So 1 loop-a-doop, 2 loop-a-doop, 1 loop-a-doop, 2 loop-a-doop. And then that would give me a whole number here, right? So it would be 254, which is really what this is right here. So what's actually happening when you're doing these loop-a-doops is you're really multiplying by 100, right, like I did here, and then 100 like I did up here. So this is really showing you much better than the loop-a-doops show you what's actually happening when you move the decimal. With that said, let's get rid of this and start with a clean slate to solve this problem. And here we have it. We've got 889 being divided by 254. As you see, I wrote my 2's, my 5's, and my 4's down. And then if I need to estimate, I'm going to bump this up to 300, so I wrote my 3's down as well. So without further ado, let's go ahead and get started. And 254 will not fit into 8. It will not fit into 88, but it will fit into 889. So I am going to use my 300 as a estimation to figure out how many times it'll go in there. And if each of these, this has 2 zeros, so I'm going to imagine that all of these have 2 zeros behind them. So there would be 300, then 600, then 900, which would be a little bit too much, right? So the 3 would, to be honest, the 3 will probably fit in there, but I'm going to use 2 as my estimation because I'm trying to stay consistent with the estimation here. So that'd be 1, 2. So I'm going to plug a 2 right here, right? So I'll plug a 2 right there, and then I'm using the real numbers now. So 2 times 4 is going to give me the 8 there. So drop an 8 right there. And then I've got 2 times 5, which will give me 10. So drop a 0 and carry the 1. Drop a 0, and then I'm going to carry my 1 right over there. And then I've got 2 times 2, which is going to give me 4, plus this 1 is going to give me 5. And bam, there we have it. And now I'm ready to subtract. And if I look here, I've got no trouble here, and none there. So I'm actually really ready to go and just do my subtraction, right? So I'm going to add my next area box in here. And then I've got 9 minus 8 is going to give me 1 right there. 8 minus 0 will give me 8 right here. And then 8 minus 5 is going to give me a 3 right here, right? So I'm going to look here, and I can see that 254 certainly will fit in there one more time. So I'm going to add another 1 above there, and then 1 times 254 is going to give me 254. So 254, and then I'm going to subtract. Before I do, I got to look for trouble coming, and this time I've got it, don't I? Whoa, that's running away from me. Big bad blue bird is, oh my goodness. Hey, blue, quit trying to run away from me. All right, let's go here. All right, so now I'm going to borrow from the 8 to turn this into 11. So borrow from here, turn that into 7, turn the 1 into 11. I've got no trouble here and none here, so I'm all good to go. So let's go ahead and create our next area box, and I'll do that right here. Bam. Excellent. And 11 minus 4 is going to give me 7. And then I got 7 minus 5 is going to give me 2. And then I've got 3 minus 2 is going to give me 1, right? And then I'm good to check over here. Now, 127 is not enough for this to go in here, is it? So I've got to add decimals, don't I? So what I'm going to do is I'm going to add a decimal in all of these places all the way up, and then I'm going to add a 0 in all of these places, right? Because as I've said in my other videos, anytime you have a number, you can add a decimal and as many zeros as you want, and you will not change that number. So we can add these zeros here. So now I'm looking at the 254 going into 1,270. So let's go ahead and look up here and see. We're going to use our 3's as our estimation. Actually 300, right? So these 3's, you got to imagine each of them have 2 zeros behind it. So it would be 300, 600, 900, 1,200, and then 1,500 would be too much here, right? So what I want to do is come back here to the 1,200, which means I'm going to multiply by 4. So I'm going to plug a 4 right here, but it's not actually a 4, it's actually a 0.4, right? And now I'll work with the real numbers. 4 times 4 is going to give me 16. I'm going to drop my 6 right here and my decimal, and then I'm going to carry my 1 right over there. And now I'm going 4 times 5, which is going to give me 20, plus this 1 will give me 21. I'm going to drop the 1 and carry the 2 right there. And then I've got 4 times 2, which is going to give me 8, plus 2 is going to give me 10. So I'm going to drop a 10 right there, and then I'm going to subtract. Now, before I do, I got to look for trouble coming. I have trouble coming right away, don't I? So I'm going to borrow from this 7, turn it into a 6, and then turn this 0 into 10. I no longer have trouble here. I have no trouble here, and none there. So I'm ready to add my next area box. And then I'm going to plug that in right there. 10 minus 6 is going to give me 4. I'm going to drop that decimal, just like the buttons of a shirt, right? And then I've got 6 minus 1 is going to give me 5. 2 minus 0 is going to give me 2. And 1 minus 1 zeroes out, so I'm good to go. Let's come on up here, and we look, I got 254, and right here, if you ignore the decimal, I got 254. It will fit in there exactly one more time which is lovely. But it's not really a 1. It's actually a 0.1, right? And then I'm going to take 1 times 254, and that will give me 254. However, I also have the decimal there, so I'm going to drop that decimal. And really the decimal is also because I'm actually multiplying it by 0.1, right, instead of by a whole number 1. And then also you can think of it with area division as just lining up the decimals like the buttons of a shirt, right? And then finally, 25.4 minus 25.4 is going to zero out, and that is perfect. So now all I have to do up here is add this all up. So I'm going to do that right now, and I'm going to draw my line here, and I'm adding up like this here. And I got in my ones column, I got 2 and 1 is going to give me 3. I'm going to bring my decimal straight on up, and then I've got 4 and 1 is going to give me 5. And right there, my friends, is your answer, 3.5. But let's go ahead and look back at our scenario that we've got here with Billy Bluebird, right? Remember, he said that he was over 4 inches tall from the tip of his talons to the tip of his tail feathers, right? And what we found out was that in actuality, he was 8.89 centimeters tall, and there are 2.54 centimeters per inch. So we divided 8.89 divided by 2.54, and we found out that Billy Bluebird is actually 3.5 inches tall, right? So is he over 4 inches tall? No. Sorry, Billy Bluebird, but you are not. You are 3.5 inches tall, and hey, that is how you solve this problem. Hey, if you made a mistake anywhere along the way, no worries at all, my friend. Pause your video, fix your mistake. That is the fastest way to learn. Until next time, I hope you have a fantastic day. And now, on to counting by the numbers. This is a great strategy for anybody who does not have all their multiplication facts memorized. Counting by threes. Ready? Here we go. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Counting by fours. Ready? And 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Counting by sixes. Here we go. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Counting by sevens, here we go. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. And counting by eights, here we go. 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. Counting by nines, here we go. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90.